Hey y'all, welcome back. Let's go ahead and go through homework 10.3. We're just practicing more of these rational function problems. So we've got a big old table on the front page here where we're going to find all the different characteristics, and then we'll do look at some of the graphs on the back. But before we start to analyze any of these, I'm going to go through each one and show you what the factors are supposed to be. So like if we factor the numerator of this second one, and I'm going to skip over the first one because this is already in factored form. I don't need to factor anything. But if I factor the numerator here, I can factor out an x, and I'll have x times x plus 5 as the numerator. Let me make that a little smaller so we can squeeze it in there. Let's see here. Pardon. There we go. Make this kind of, just write this up here. And then for the denominator, this is going to factor into a product of binomials, specifically x plus 5 and x plus 2. So you might notice right away that we've got a factor that is the same in both the numerator and the denominator here, the x plus 5. So that's going to indicate that we're going to have a hole on this one. But we'll come back to that when we go through the analysis here. So for this third one, I'm going to factor the top. That's going to be x minus 3 times x minus 4. And the denominator is a difference of two squares, so I can factor that as x plus or minus 3. So one way to write that would be x minus 3 times x plus 3. This one also will have a hole at x equals 3. You can see we've got that same factor on the numerator and the denominator. For the last one, the denominator doesn't need to be factored at all, but the numerator can be factored, I think, hopefully. Let's see, we've got 2x minus 3, and then, well, actually, can it be factored? Let's see here. Oh, yeah, it definitely can be. This should actually be 2x minus 1, and then x plus 3. So we do have, actually, so 3 of the 4 of these are going to have holes. This first one doesn't have a hole, but each of these others do. So let's go through the vertical asymptotes. This is are going to be those lines that partition the graph out into the different portions, the different intervals rather. And we get these by setting the denominator equal to 0 and solving, although we can ignore any x values that correspond to holes. So for this one, we just get 1 at x equals 7. This one, we get 1 at x equals negative 2, okay? The x plus 5 is going to correspond to a hole rather than the vertical asymptote. Okay, we've got 1 here at x equals negative 3, and we got this, actually the same one here, x equals negative 3. Now for the horizontal asymptotes, what we do there is we compare the degrees of the numerator and the denominator. If they are the same, like on this one or this one, or actually all but the last one, then we divide the leading coefficients. So this would be like 2 over 1, which is just 2. This one would be 1 over 1, which is just 1. And this third one is also 1 over 1, so that would be 1 as well. Now for this last one, the degree on top is bigger than the degree on bottom, so this one actually has no horizontal asymptote. So I'll just say none. All right, so that's the vertical asymptotes, the horizontal asymptote. Now let's talk about the holes. These occur wherever we have an x value that makes both the numerator and the denominator 0. So for this first one, there are no holes. For the second one, we do have a hole at x equals negative 5. So we know that the x value is going to be negative 5. To find the y value, we need to plug in negative 5 into what I call the hole equation, which is just the function with the like or the common factors canceled out. So it would just be x over x plus 2. Basically I'm going to plug in negative 5 into this. Okay, so I'm going to replace the x's with negative 5s, and I get negative 5 over, let's see, negative 5 plus 2 would be negative 3. So a negative divided by a negative is a positive, so we just get 5/3 here. For the next one, we've got an x value for our hole at positive 3, and then if I plug in 3 here and here, I get negative 1 over Let's get that negative with the 1 there. And then if I plug in 3 on the bottom, oh, wait a minute. Let's try that again. 3 minus 4 is negative 1, and then 3 plus 3 is 6. So we get actually negative 1/6 as our y coordinate. For the last one, we get negative 3 as the x value of the whole. And then if I plug in 3, so there's not a leftover factor here in the denominator for me to plug it into. So the only factor left over is just a positive 1. So we really just need to plug it into the top, which is going to be negative 6 minus 1. So that's negative 7. All right, so those are the first 3 rows. Let's take a look at the rest of these. Actually, you know what? I actually don't have a vertical. I was working too fast here. This negative 3 is going to correspond to a hole. I bet you. I bet some of y'all, as you're going through this, are thinking, "Wait, that's not right." Yeah, so I guess that's what happens when you try to work too fast. So there's actually no vertical asymptotes here. Let me go ahead and fix that. That's not what I wanted. Here we go. So we're just going to say that there's none here. All right, so the next things to find are going to be the intercepts, and then we'll make a note about the domain and range, and we'll go from there. Now, I might have to do a little bit of scrolling here to get all these to fit, but it looks like the next thing I'm looking for are the x-intercepts. So I'm going to set the numerator equal to 0, and then solve for x, although I can ignore any factors, like on this one, the x plus 5, because those are going to correspond to wholes rather than x-intercepts. So the first one is going to be at positive 1/2. So I'm going to have positive 1/2 comma 0. And then for the second one, I can just plug it into 0, so it's just going to be 0. So we have 1 at the origin. And we can actually take a quick shortcut here. If we know that we're passing through the origin, then that has to be the same. Then we get the y-intercept will be the same actual coordinate there. For the third one, we can ignore the x minus 3 and just plug and find out what value makes this 0, and so that would be 4. And for the last one, we can ignore the x plus 3's and just figure out what makes this 0. So that'd be 1/2. So we get actually the same x-intercept as the first one here. Oh, try to type that in there. There we go. Okay. For the y-intercept, we're going to plug in 0 everywhere we see x. So we can just I would recommend you stick with the standard form here rather than the factored form, just because we know all the terms with x are just going to 0 out. And so here we get negative 1 over negative 7, which is just 1/7. A negative divided by a negative is positive. So I'm going to get 0 comma 1/7 as my y-intercept for the first one. We already found the y-intercept of the second one, so we can skip that and go to the third one. So we'll have 0, 0, 0, so that's just going to be positive 12 over negative 9. So positive 12 over negative 9 can be reduced to negative 4/3. And then for the last one, let's see here. We've got, we can ignore the x plus 3, or I'm sorry, we're looking for y-intercept. So here we're going to plug in 0 here, here, and here, and that's going to leave us with negative 3 over positive 3. So our y-intercept here should be negative 1. Now we start talking about domain and range. The domain is going to consist of all the x values except for where the function's undefined. And these rational functions can be undefined in 2 different places. So they can either be undefined at the vertical asymptotes or the wholes. So really, it's usually just easier to state the domain by saying what it's not. So the domain here is going to be x is not, throw in that little not symbol, not equal to. I don't know why it's not going in there. Let's try again. There we go. So it's not going to be equal to the vertical asymptote at 7. And then if we had a hole, we would call out that x value as well. But it's just going to be that x can't be 7. But it can be all other numbers. So for the next one, we can say x can't be negative 2, and x cannot be negative 5. So at both negative 2 and negative 5, the function's undefined. So we're going to say that x can't be -2 or -5. For the third one, we're going to say that x cannot be -3 or 3. So it cannot be plus or minus 3. And then for the last one, we'll say that, now we don't have a vertical asymptote. The only x value that make this undefined at all will be the one that corresponds to the whole, which is that -3. So we'll just say x does not equal -3. Now, as far as the range is concerned, it's going to be undefined at the horizontal asymptotes, unless you happen to have a crossing there. And it's also going to be undefined at the y values of the holes, unless, of course, it's defined elsewhere. The range is not something I'm going to ask you too much about, but we can go ahead and write out what these would be. For this one, y is just not going to be able to be 2, which is the horizontal asymptote. Okay, and you can double check and make sure that this actually doesn't cross the horizontal asymptote, and it doesn't. So we get y cannot be 2. I'm sorry, negative. No, yeah, 2. For the next one, we're going to say y cannot be 1, this horizontal asymptote, and it's also not going to be the value for the whole, which was 5/3. So y cannot be 1, and it cannot be, oops, there we go, and it can't be 5/3. For this one, we're going to say that it cannot be, let's see here, it can't be 1, and it can't be -1/6. And then for the last one, I'm going to say, oh, there's no horizontal asymptote, so we don't need to worry about that, but there is a hole at -7, so y can't be -7. All right, so those are going to be the ranges of each of these. Let's take a look at, yeah, I guess that's it. So let's take a look at the next page. All right, so on the back page here, we're going to match the equations. So again, I'm just going to run through these and factor them out so we can identify our holes, and hopefully that, well, since we're just matching, I mean, that should kind of answer all of the questions we have here. So the denominator here is going to be x minus 4 times x plus 1. So no holes on this one. Okay, kind of nice. We've got a bigger on bottom, so we've got a horizontal asymptote of 0. We got 2 vertical asymptotes. So the fact that there's no hole and we've got 2 vertical asymptotes, we don't really need to analyze it much further. It's going to be C. So for the next one, we can factor that denominator as x plus 4 times x plus 1. So this one should have a hole at -4. Now both of these two have a hole at -4, but this one in the middle, B, also has a vertical asymptote here at -1. So since this one doesn't have that, we can be pretty confident that this is going to be B. Now for the last one, the only one choice left here is A, so we're just going to go ahead and write that. But if we were to go ahead and factor this, we'd get x times x plus 4. And if we're just trying to check and make sure we did get the right one here, we should have a hole at -4, which was the same as the last one, so that's not really helpful. But we do have an x-intercept at 0, which is reflected here. So we are good to go there. We got C, B, and A for this matching. Now down here, we're trying to write the equation, so we're going to work backwards. Okay, so the trick here is we're going to try to write a function, given all the information we have, and I want to show you how the whole will play into that as well. So for this first one, notice that this is just a linear function. So if I just write the function and sort of ignore the whole, the slope here is going to be 1, right? Because you're going up 2 over 2, up 2. So the slope is 1x, and I'm just using the old mx plus b format here to write this. So since the slope is 1 and the y-intercept here is 2, I could write this equation as y equals x plus 2. But if I just left it that way, it would just be this exact same line but no hole. I need that hole to be there, and that hole, it looks like it's happening at x equals 3. So 3 comma 5. So if I want to inject a whole into this function, what I need to do is actually include an extra factor here. So I need a factor on top and bottom that will give me that whole of x equals 3. So I'm going to put x minus 3 on top and x minus 3 on the bottom, and now I've got the function I need. So I'm pretty much done here for this one. If you want to multiply it together, you can. I don't think it's really necessary, but if you did multiply them together, you would get x squared minus x minus 6. So either one of these answers is fine. For the second one, we'll take a similar approach here. We'll start by just writing the function, pretending that the whole doesn't exist. So the slope here is 1 again, okay, so just 1x, and then the y-intercept is 2. So this would be the function that would give the line without the hole. And so now let's force there to be a hole there by multiplying this by x plus 2 over x plus 2. Okay. Now, if I do that, I can, I'm done. That's my function. If I wanted to multiply these together to just kind of write it in standard form, I can FOIL these out, and what I'll get is x squared minus 4. So either one of these two would be fine for this one. Now, moving down here to the bottom, we're going to close out this this homework video, which has kind of been on the shorter side, I think. I don't feel like I spent a ton of time on this one. So here, we're going to start with y equals, right? And then we want to look at a couple different things. So let's start with noticing that there's no x-intercepts here. So I'm not going to have any extra factors. I do have a hole here at, let's see, what's my scale here? 2, 4, 6. So this is going to be at -5. So let me just start by making sure I have that hole in there. And I'll have x plus 5 over x plus 5. Now, this is basically just, nothing. This is just where, going to give me the hole here. What I need is for a vertical asymptote to be at -3. So if I've got a vertical asymptote at -3, then I'm going to have another factor that's x plus 3. I do have a horizontal asymptote that's 0, so my denominator needs to be a higher degree than my numerator, which it already is, so I don't need to change anything based on that. My y-intercept, which isn't clearly labeled, but if I multiply this out and I get x squared plus 8x plus 15, what I get for the y-intercept would be 5 over 15, which is 1/3, and that seems like that could be right, so I don't need to change anything there. I don't have an x-intercept, which makes sense because if I cancel these out, I'd just be left with a 1 up here and I would not have a factor. So I think we're pretty much done. You can write it in factored form or in standard form, but either one of these would produce this graph. Now I'm going to come up with an equation for this last one in a similar way. I'll start by making sure my hole is in there, so I'll have an x plus 4 over x plus 4. So I know that I'm going to have a hole at -4, which I do over here. And then let's see here. I've got a vertical asymptote at what is that? +4. So I also need one that's going to be x minus 4 here. Let's see here. Something still seems off. What is it? Something is not right. You know what it is? I need to be able to flip this over because check this out. Let's go ahead and multiply this together and you'll see what I mean. But if I have x plus 4 over x squared minus 16, this gives me a y-intercept that's -1/4, but my y-intercept needs to be +1/4. So what I need to do is I need to basically flip this whole thing around, and I can do that by multiplying everything by -1 essentially. So I can either put that in the numerator and the denominator. I'm going to go ahead and I guess put it in the denominator, or I'll just put it out in the front. Well, no. I guess I need to pick one. So I'll put it, I guess I'll put it in the denominator. So put a negative here. And when I do that, that's going to make this negative and this positive. So kind of a weird little fluke here where this is going to be flipped from what it should be. But that's how you can fix that. Whenever you negate a function, it flips it over the x-axis. And so we can accomplish that just by multiplying by -1. So that's all the problems on this homework. Hopefully at this point, through 2 lessons and 2 homeworks, you have a pretty good idea on how the rational function equations relate to the graph and are able to kind of go back and forth. So I hope you all have a great day, and I'll see you next time.